I gave you the example of Mary, the visual neuroscientist who's blind, who knows everything about the physics of light and knows everything about the photosensitive cells in the retina and knows everything about how these transduce light waves into neural impulses and how they travel along the optic nerve to the lateral geniculate to the occipital cortex, and what the occipital cortex does with these spike trains of neural signals, but she has never experienced vision. So even though she knows everything that there is about the mechanism of vision, about the underlying functional explanation of how vision works, one day when, thanks God, she suddenly acquires the gift of sight, she learns something completely new about vision, which is what it feels like, what the color red, the quality of blue, what it actually looks and feels like. There's something that it is like of vision, was not accounted for by everything she knew about its mechanisms. So it's on this basis that Chalmers says that the functional account, the mechanism, does not explain the experiential feel of consciousness. And that, I said, leads us to have to ask this question. And again, I'm putting it in big letters like this because I want to make clear that this is a question that I have to answer if I'm going to address the hard problem of consciousness. And the question is, why is the performance of these functions accompanied by experience? Why doesn't all this information processing go on in the dark, free of any inner field? There's another philosophical point I didn't make yesterday, which I want to just make quickly here, which is actually a point that Locke made already, which has to do again with the curious relationship of conscious qualities, experiential qualities, the curious relationship of these things to the physical. And the point is that all of us experience color. I'm just using color as an example because vision is so often used as the model example of consciousness. I experience something that is red. These chairs, I experience them as orange. You also are doing so, but I don't know what your experience feels like to you. It may be that what I'm calling orange and what you're calling orange, in fact, you are seeing an entirely different quality. You just call it orange. But actually, if I could get inside of your mind, I'd say, no, but that's green. That's not orange. First of all, that's one philosophical problem, the problem of other minds. I can never know what it's like from your point of view because the mind is something subjective. But more interestingly, it clearly makes no difference. Because if you saw blue when I see red, and we both call it red, but actually the quality that you're experiencing is blue, it would make no difference to your behavior. If you think about it, think it through logically, it would make absolutely no difference. And again, this is the point, that the qualities of experience seem to be in a different dimension, in a different realm from the physical, causal matrix of the universe, because it makes no difference. Okay, so I then say, this is where I got to last night. I said, well, the reason why these philosophers get themselves into such a perplexed state about consciousness in relation to the functional mechanisms of cognition is because cognition is not intrinsically conscious. Cognition is, in fact, intrinsically unconscious. And I know Freud said this 100 and something years ago, but it was rediscovered in the late 20th century by cognitive neuroscience. The idea that cognition is fundamentally unconscious was a great surprise to us, but it is really absolutely undeniably the case. And I gave you yesterday the famous example, the most illustrative or the most demonstrative of the point that I'm making is when it comes to higher cortical functions which are uniquely human, even reading, which is decoding symbolics, these symbolic images and turning it into meaningful cognition. Even this function can be performed unconsciously, as we can demonstrate with tachistoscopic presentation of the image. The person, the experimental subject, does not even realize that they've seen anything at all, let alone that they've seen words, let alone that they've read and understood those words, which influence their behavior, so we can demonstrate objectively that they have read and understood and been affected by their understanding of the words. They have no awareness whatsoever that they've seen anything. So clearly cognitive functions, and I'm just giving you one tiny example there, the same applies to memory, the same applies to perception, the same applies to route finding, the same applies to everything in cognition. So much so that eventually the question was asked, seriously asked in cognitive neuroscience toward the end of the 20th century, what is the consciousness for? It doesn't seem to add anything at all. And somebody in the audience asked about Benjamin Libet's experiments with free will, where it is demonstrably the case that even free will, the sort of pinnacle of consciousness, my capacity to decide for myself at any moment whether to do something or to not do it, it's entirely up to me, up to my consciousness. Benjamin Libet showed that that's in fact not the case. That with his famous experiment, he was able to show, using EEG over the supplementary motor area, that the readiness potential, the physiological evidence of the initiation of a movement precedes the conscious decision to execute the movement by 300 milliseconds. And so consciousness seems in fact to not be doing anything at all. So remember, this I'm saying is why the philosophers have been so perplexed by why do the mechanisms of cognition why do they not seem to account for consciousness? I gave you the example of this famous review paper which makes all the points that I've just made. Now I carry on. This is today. It's no longer yesterday. In order to further illustrate the point, not only that the functions of cortex are not conscious, are not intrinsically conscious, which is the point that I've just been making, I now want to make the further point, which is that consciousness does not require cortex. So I've said cortex does not inherently produce consciousness, and in other words, what it does is not inherently conscious. It can do all the same cognitive tricks without consciousness, which begs the question, where does consciousness fit into all the causal mechanisms of cognition? And now I'm saying you can actually take the cortex away and you still have a conscious patient if you take the cortex away early enough. This is the scan of a 3-year-old child who was born without any cortex. It's a condition called hydranencephaly, not hydrocephaly, hydranencephaly, no brain, just CSF, or at least no cortex, just CSF. And here she is. And you can see she's awake. She goes to sleep at night. She wakes up in the morning. In that sense, she's conscious. And also she has absence epilepsy. So even her parents can see now she's lost consciousness. Now it's back again. So here's somebody with absolutely no cortex, and yet she's conscious. And it's not only a matter of consciousness in the sense of wakefulness, but also consciousness in the sense of reactivity, appropriate reactivity to emotional stimuli. So here, for example, her baby brother is put on her chest, and she goes, ah! And she expresses pleasure at the experience of her brother being placed on her chest. Now remember, that experience cannot be pictured by her. She cannot have a cognitive cortical image, let alone an idea of her brother. There can't even be any representation in cognitive cognition, in cognitive consciousness, of her brother being placed on her chest. There is no image even of her chest, of a me. All that there is this experience which I'm going to explain to you in a moment. Affective experience, which clearly does not require cortex. And this is just one image. Of course, I can't expect you to believe on the basis of one image everything that I'm saying, but this is an oral presentation, and I can only give you illustrations. I can't give you all the evidence, so that's why I gave you the publications at the beginning to look for more detail. Just to show you it's not one and only child. All these kids are like that. No cortex, but they're conscious, and they show full emotional reactivity. They show joy, they show frustration, they show attachment, all of the basic emotions. So now we have to ask, in what sense then are these children conscious? If they're not cognitively conscious, in what sense are they conscious? And what I'm saying is they are affectively conscious. Before I move on, because we are, many of us, psychoanalysts, I want to remind you of what Freud had to say on this matter. Freud, the discoverer of the unconscious, the person who 100 years before the cognitive neuroscientists said the same thing, said cognition is not intrinsically conscious. Most of our cognitive operations are, in fact, performed unconsciously. Only a small fraction are conscious. All these things, Freud said, all these things we have rediscovered 100 years later. But even Freud said, this does not apply to affects. He says it's surely of the essence of an emotion that we should be aware of it. That is, that it should become known to consciousness. Thus, the possibility of the attribute of unconsciousness would be completely excluded as far as emotions, feelings, and affects are concerned. Now, let me be clear what this means. You can speak of vision that is unconscious. You can see unconsciously. You can speak of memory that is unconscious. You can learn and remember unconsciously, etc. All of these cognitive operations. But you can't speak of feeling unconsciously. How can you speak of feeling without feeling it? And that is the meaning of the word affect or emotion or feeling. Of course, there are all sorts of problems about these words. So I want to be sure that you understand what I mean by that word. What I mean is the feeling of a feeling. The feelings exist. Feelings are part of nature. Feelings like sadness, feelings like hunger, feelings like sleepiness, these are feelings. And when you feel them, they exist. When you're not feeling them, they don't exist. So they are intrinsically conscious things. This was Freud's point. Unlike memories, cognitions, which have a persistence, they have a structure which is there, whether you're conscious of them or not. They're performing their operations, whether you're conscious of them or not. Feelings, their function is to be felt. They have their effects by feeling them, and when you're not feeling them, they're not there. So my point is, if we want to understand, if we want to get around this problem that Chalmers and Nagel and others have presented to us by saying that cognitive functions, the understanding of the mechanism of, say, vision, like with the blind neuroscientist Mary, doesn't tell you anything about the experience of vision. I'm saying that does not apply to affect. The mechanism of affect must explain why it feels like something, because that's the whole point of affect. It's to give you feelings. So the mechanism of feeling has to account for the feeling of feeling. And so I'm saying this is the right place for us to look if we want to understand the hard problem of consciousness. Now, this is not a philosophical argument only. This is in fact where the empirical evidence should lead us. If you want to understand consciousness, even from an empirical point of view, everything points to the fact that consciousness in its fundamental form is affective. And this is what I'm going to argue to you now. On this slide, I just have two images of the brain, which I've color-coded. And down here, I have two references. The one is to Maruzzi and Magoon. And let me tell you about their work first of all. It was assumed until 1949, their paper, it was assumed by them and by all neurophysiologists, which is what they were, and indeed by all of us, philosophers, lay people included, that consciousness flows in through the senses, that consciousness is bound up with the perception of the outside world, with our sensory organs. So it came as a very big surprise to Maruzzi and Magoon to discover that this is in fact not the case. You can sever all inputs to the brain from the sensory periphery, and indeed, as I showed you, you can even remove the cortex, which represents these sensory inputs, and still you have a conscious being there. If you decorticate animals, decorticate mammals, this has been done with many different mammals, you do it when they're young enough, then you have a perfectly, not perfectly, but you have, it's very hard to distinguish between a decorticated, say, for example, kitten and one that's not. Students really have great difficulty telling you which one is which. Jaak Panksepp loved to tell the story that when he did this with his students and asked them which of these are the decorticated animals, they chose the decorticated animals were the ones who they thought had cortex, and the ones who did have cortex were the ones that they thought were decorticated. Why is that? It's because, in fact, the ones without cortex are much more lively. They're much more responsive, and there's something very interesting in that. Maruzzi and Magoon found that to remove consciousness, it's not a matter of removing cortex, it's not a matter of removing the sensory inputs into cortex. It's a matter of removing these structures, these purple structures, and I'm only showing some of them on the screen, which they called the reticular activating system. What Magoon and Maritzi showed was that if you make a lesion above, in fact, they hadn't yet included these non-specific thalamic nuclei. If you make a lesion above the midbrain reticular activating system, thereby separating it from the cortex, then the cortex loses consciousness. So this demonstrates that consciousness is not an intrinsic property of cortex. The consciousness is supplied by the upper brain stem, by the core of the brain stem, traditionally called the reticular activating system. This was a great surprise. This was in 1949. In the early 1950s, it was demonstrated very clearly that this is where the mechanisms that wake you up in the morning and put you to sleep at night, they are located, in fact, in the pontine brainstem, all part of this reticular activating system, these purple structures on the screen. So consciousness does not flow in from this outside. Consciousness is not an intrinsic property of perception. Consciousness is not an intrinsic property of cognition and of cortex. All of that I've said already. We're just saying it again from a different point of view. So where does consciousness come from? It comes from inside the brain. It is an intrinsic property of the upper brain stem. It's an endogenous property of the brain. Consciousness is generated from within. This was such a surprise that Maritzi and Magoon didn't know what to do with it. And so what they did was they changed our definition of consciousness. And they said, we'll keep the old theory intact, that consciousness is cortical, that consciousness is representational. We'll call this the contents of consciousness, the qualities of consciousness. And we'll now invent a new thing that we'll call the level of consciousness. And so they said what the upper brain stem produces, what the reticular activating system produces, is arousal, is wakefulness, is this quantitative thing of volume control. How much consciousness? It's quantitative as opposed to qualitative. It's a level of consciousness rather than the contents of consciousness. This is how they explained it, and we still measure this level of consciousness today on a 15-point scale. It's a matter of volume control, except that's not true. And that's why I put Panksepp's name down there, because Panksepp was the person, the neuroscientist who brought this most forcibly to our attention, that the so-called level of consciousness produced by the upper brain stem is not just a quantity. It has a quality of its own, and that quality is called affect. Now remember what I said to you earlier. I said that the consciousness of the cortex depends upon the arousal systems of the upper brain stem, that these enable cortical consciousness, that these activate cortical consciousness. And everybody was happy to believe that, as long as they understood that all that this is volume control, or the on-off switch. It's not consciousness itself. Consciousness itself, somehow they managed to fudge it and say cortex produces consciousness itself, and that this is just the volume control. They were happy to accept that, but now I need to make again the point that actually what these structures produce is not just volume. They produce a quality. This quality is called affect, and I'm going to give you some of the evidence for it in a moment. And again, remember, I can only give you the briefest of headlines. You need to read the articles for a full account of the evidence for this. So what this means is that cortical consciousness relies upon affective consciousness. That affect is the fundamental, basic, raw, elemental type of consciousness is affective consciousness. By the way, you can make tiny lesions in the reticular activating system. In the parabrachial nucleus, for example, you can make a 2 cubic millimeter lesion. And that's a tiny, tiny, tiny lesion. 2 cubic millimeter in the parabrachial nucleus will cause coma in a human being. And there's studies looking at coma-producing lesions. What is the minimal tissue damage required for producing brainstem coma? And it's 2 cubic millimeters of parabrachial nucleus. So this gives you a sense of the relationship of this tissue to that tissue in terms of where the consciousness comes from. And now the point that I'm making is that it is not just volume, it is affect. That what these structures produce is qualities of consciousness called affect. And there are many different ways in which I can demonstrate that. In fact, I've already demonstrated it in one sense by showing you the hydranencephalic children. I showed you that these children are awake, and not only awake, they don't have blank wakefulness. They're awake and sentient in the sense that they feel things. And I showed you a little visual example of these children showing emotional reactions. So that already makes the point that affect is not generated in the cortex, which means it must be generated in the brain stem. And the next way in which I can illustrate this point for you is, for those of you who are psychiatrists, is to remind you that most of the drugs that you give your patients are in fact acting on the reticular activating system. So, for example, antidepressants, SSRIs, which act on the RAFE nuclei, these are the source cells of serotonin. In other words, serotonin, which modulates cortical functioning, actually is part of reticular activating system function. The same applies to antipsychotics. The source cells for the dopamines, the dopaminergic systems that your antipsychotic drugs act on, those source cells are in the ventral tegmental area, again, part of the reticular activating system. And the same applies to, in the case of the nucleus locus coeruleus complex, these are the source cells for noradrenaline, which is again one of the favorite targets of your anti-anxiety drugs. So drugs that treat anxiety, drugs that treat depression, drugs that treat psychosis, these are psychiatric drugs, which you're not trying to wake patients up and put them back to sleep again. It's not volume control. What you're doing is you're trying to change the quality of their consciousness in the dimension of consciousness that we call affect, feelings, emotions. So clearly these things are produced, the state of consciousness that is produced by the upper brain stem has a quality, and that quality is affect. And I'm saying this is the basic, the foundational form of consciousness, because without this form of consciousness, all the other type of consciousness disappears. As I said, just the tiniest 2 cubic millimeter lesion in the parabrachial nucleus wipes out all consciousness. And now I'm saying to you, this is affective consciousness. I've spoken to you about children without cortex. I've spoken to you about psychiatric drugs. The same applies to deep brain stimulation. Oh, this slide, I didn't know it was coming. I'm busy talking about this, content versus level. I'm saying it's not a matter of content versus level. Brainstem doesn't produce a level of consciousness. It's a matter of channels of consciousness versus states. This is Marcel Mesulin's terminology. I think that's a much better term for what we're talking about. And consciousness, if I had more time, I would go into this in more detail, but I don't have more time, so I won't go into more detail. The important thing is most people think of what neurons do when they communicate with each other. They think of it in terms of neurotransmitters and neurotransmission. This is these channel functions, information transfer along channels, which is how cortex works, and not only cortex. I told you already, what cortex does is not intrinsically conscious. Cognition is not intrinsically conscious, and in fact, neurotransmission is not intrinsically conscious. What those upper brainstem neurons do, the reticular activating system, they don't pass messages. What they do is they arouse cortex, they modulate cortex, they modulate neurotransmission. They switch it on and switch it off. They modulate how much, they facilitate. They can actually, like in sleep, all those sensory signals are still coming in, but modulation, the toning down of the arousal of cortex makes that neurotransmission not be conscious, but it's still busy happening. And the same applies to all cognition. So it's very important to understand that what the upper brainstem is doing is not transmitting signals, it's arousing the parts of the brain that's transmitting signals, and we call that neuromodulation. So the drugs that you psychiatrists use are neuromodulators. They're acting on, like the serotonergic and dopaminergic and noradrenergic, histaminergic, cholinergic systems. These are modulatory systems. These are images from DiMaggio's famous PET study of some basic emotional states: sadness, anger, happiness, fear. And you notice where the activation is in subcortical structures. particularly brainstem structures. If you look at the cortex is in fact deactivated. That's why it's blue, purple. The cool colors are deactivation. That's an image, another method for demonstrating the point that I'm making. Here is a very intense affective state. It's known as orgasm. It's quite nice to see where the feeling comes from in orgasm. It doesn't come from the cortex. It comes from the transitional zone between a mesencephalon and diencephalon. It's a brainstem phenomenon. All of this, I'm trying to make the point that what the brainstem is producing when it's producing this background state of consciousness is affect. It has quality. Here's a remarkable study of a patient who was having deep brain stimulation. They were aiming for an area just above where the stimulator went. It went into the substantia nigra, which again is part of the reticular activating system. And this patient, who had absolutely no psychiatric history, when they stimulated the substantia nigra, she went into a profound depression, absolutely deep suicidal depression, just like that, in seconds, on the operating table. I won't read you this whole thing because we don't have much time. Here's the end of her description. There's the reference. It's Blomstedt et al. 2008. When they then moved the stimulator, or at least moved which of the nodes was activated up to where they were actually intending to stimulate, then the depression disappeared, again within seconds. So I'm really just giving you an impressionistic account. You must remember this is not a proper scholarly, thorough review of the literature. I'm just giving you an impression of the sorts of evidence that we have for the argument that I'm making to you, which is that consciousness is not a cortical property, consciousness is not a cognitive property, consciousness is an upper brainstem or core brainstem reticular activating system property, and it is affective. It feels like something to be awake. So consciousness in its raw, elementary, basic form, the foundational form, which is necessary for all of this cognitive type of consciousness, it's necessary to first have this brainstem type of consciousness, and it has a quality, and that quality is called affect. And so, dear colleagues, the argument that I'm making is to go back to the hard problem, to go back to the question that this talk is all about, is that if we want to understand the function of consciousness, if we want to understand the mechanism of consciousness, we should not be looking at things like vision, because vision is not intrinsically conscious. Consciousness is not about vision, or any other aspect of perception, or any other aspect of cognition, or any other aspect of what the cortex does. Consciousness is about what the upper brainstem does. It's about what the reticular activating system does. It's about feeling. And the mechanism of feeling is what we should be looking to if we want to understand what consciousness is for, how and why consciousness arises. It's an entirely different question than the one that the philosophers and the neuroscientists inspired by them have been looking at. They've been looking in the wrong place for the mechanism of consciousness. They should be looking here. Panksepp looked there, and Panksepp came to some conclusions. DiMaggio looked there, eventually persuaded by Panksepp to look there, and he came to the same conclusions, which is that, of course, affect does have a function. Affect does have a mechanism, and it actually does something. I told you earlier about blue and red, and I said you could swap them around. It would make no difference. Does the same thing apply to affects? Just imagine two affects. The one is separation distress. Mama, you want mommy to be close to you. That's the feeling of panicky separation distress, and that's what you do when you have that feeling. Then there's another feeling called fear, which is, and you run away. You want to get away from this thing that's making you scared. These are two different feelings. Imagine if you swapped them around. Would it make no difference? When the lion is coming at you, you go, Mama, and you hug it. It'll kill you, okay? If you're feeling separation, you've been separated from your mummy, so what do? You run away from her. It will kill you, if you can run. So the point is that unlike perceptual qualia, unlike cognitive qualia, affective qualia do actually do something. There is an intrinsic connection between feelings and action. Affects impel you to do something. That's what they're there for. So what we're busy doing now is addressing the question, and again, I don't have time to go into this in sufficient depth, I'm just sketching out in very broad brushstroke headline terms the structure of this argument. And the conclusion that Panksepp and DiMaggio and others have come to is that the mechanism of consciousness, the mechanism of affect, is homeostatic. And I'll now explain that to you. Affects do have a mechanism, and it is a basic... Oh, let me just introduce this word here. That affects are deviations from homeostatic settling points, and I've introduced the word here, surprise. This is a technical term in an aspect of computational neuroscience called predictive coding. So in predictive coding, the whole thing revolves around these terms, that you predict, in the case of one of our homeostats, which is, say, core body temperature, the prediction is, this is just a technical term, I know it's an odd way of using the word, that's why I'm belaboring the point, because I want to be sure that you're familiar with this language. The animal predicts that it's going to, or us animals predict, we're going to remain between 36.5 and 37.5 degrees Celsius. That's where we aim to be, that's our prediction. If we deviate from that, then in this technical vocabulary, that's a prediction error. It means that this is not where you expect to be, and that's why they use the word surprise. It's a very strange terminology. Please forgive me, I have to use the terminology such as it is. So surprise is prediction error, is a deviation from where you expect to be. Now this is the argument that DiMaggio and Panksepp and others, and I accept it readily. This is the argument as to what affects are for. I've spoken to you about core body temperature, and that's actually a very good example, a very good place to start in order to understand the mechanism and the function of affect. Because again, just as much we've made the mistake of thinking consciousness is all about reading and face recognition and all of this uniquely human cognitive complicated stuff, it's not. It's actually about something much more basic. It's about affects, it's about the upper brainstem. And when we speak about affects also, we mustn't think about jealousy and guilt and envy and all of these really complicated human affects, social affects and so on. We must think about the most elementary forms. If we want to understand the dawn of consciousness, where consciousness, how it emerged in nature, in its elementary, fundamental, basic form, then we need to go back to these much more foundational principles. That's how you understand the essence of these things. The most fundamental affects are bodily affects, things like feeling hungry, or feeling cold, or feeling the need to urinate, or feeling sleepy, etc. These are affects. What defines affects is two things. The essential thing that defines affects separately from everything else in the life of the mind is hedonic valence. There's a pleasure and an unpleasure in all affects, like needing to pee, unpleasant, peeing, pleasant, okay? Being hungry, unpleasant, eating, pleasant, being thirsty, unpleasant, drinking, pleasant, being sleepy, unpleasant, sleeping, pleasant, and so it goes on. So they have valence. The second thing is that they have quality. So there is a different, it feels different to need to defecate from needing to retch, from needing to sleep, etc. Each one has its own qualitative feel. So there are different categories of affect, but all of them have valence. And it's the valence function of affect that we link to homeostasis. So the basic principle is that if you're in the settling point where you need to be, like for example, you're between 36.5 and 37.5 degrees Celsius, that's great. As you deviate out from that range, too hot or too cold, so you start to feel unpleasantly too hot or too cold. That is the mechanism of unpleasant feeling. Then you move back into the temperature range by changing your location or taking your jersey off, or whatever the case may be. And then there's the pleasurable feeling of returning back to what I've jokingly here called nirvana, which is in fact the settling point. Satiation is the technical term. Please note, it doesn't carry on and on and on. Like when you're hungry, you don't eat and eat and eat and eat and get more and more and more and more pleasure. Eventually you've had enough. That's when you're in the settling point. That's where you are where you want to be. That's the basic function of affect. And remember that it's not only valence. I'm showing valence on the screen here. there's also a quality, so that each one of them has its own qualitative field. Hunger is different from thirst, etc. Why should that be the case? Well, for the very reason that I've just told you about lions and mummies. You know, you need to know the feeling that you're feeling relates to which need needs to be met. So you can't just do any old thing to get rid of unpleasure. You have to do a very specific thing to get rid of that particular unpleasure in order to meet that biological need. The point that I'm making is a very simple one, which is that affects have an obvious place in the causal nexus of biology, of biological mechanisms, of biological forces. Affects do something. They perform an extremely important function. They tell the animal that they're in a state of need, and they tell them what it is that they need, and that influences what the animal does in order to meet that need. That's what the mechanism, the functional mechanism of affect is. Now, there's a great deal of complexity here that, again, I don't have time to go into, but I do at least need to touch on a few things. The first thing is this. The whole of the body is regulated by homeostasis. It's not only the brain that is a homeostatic organ, and it's not only mental functions that are homeostatically regulated, and in particular affective functions. There are many bodily functions that are regulated homeostatically without any awareness attached. Like, for example, the clinically notorious example is blood pressure regulation. You don't feel anything. It's just done absolutely automatically. The same applies to all of our autonomic reflexes. And in fact, the same applies to many of the bodily mechanisms that we do feel. Like, for example, energy metabolism, glucose metabolism, for example, is going on all the time. You don't have to feel hungry. That you can extract energy from the adipose tissues of the body automatically all the time. But then eventually it reaches a point where there's no more energy supply left. Then you've got to go out into the world and you've got to do something. That's when you feel it. You feel hungry, you feel thirsty. Same with temperature control. If you're too hot, you start perspiring. It's all automatic. You don't decide to do it. You don't even have to feel it. So the point I'm making is, what is feeling for? Remember what I said earlier about my definition of feeling. The feeling kicks in when the autonomic mechanism is not, it reaches its limits. And it's very important that it does have limits. As a very good example is hunger and thirst. You need to do something in the outside world. You can't just produce what you need. There comes a point where the autonomic, the vegetative part of the thing can only go so far, and then consciousness, feeling, guides the animal into the world in order to know that I've got this need. And because there's uncertainty, and this is the part that I need to emphasize, if it's a simple causal mechanism, a simple automatic mechanism, it can even be like the thermostatic control of the temperature in a room. You don't need to, the room doesn't have to be conscious. It has this homeostatic mechanism that's always doing exactly the same thing. What feeling adds is, now I'm in the outside world, I don't know whether I've met my need or not, and the way that I know whether I've met my need or not is if the feeling goes away. If the feeling gets worse, it means I'm getting hungrier, I'm getting colder, I'm getting thirstier, or whatever the case may be. And if it gets better, the pleasurable feeling means, yes, carry on doing this thing is working. So what it enables the animal to do is to feel its way through uncertain environments. So this is an enormous biological adaptive advantage. Think about it. If all that you can do is absolutely automatic and regulated, like those vegetative functions that I've spoken about, then there's no room for choice. There's no room for making decisions. You can only make decisions on the basis of a value system. What is good and what is bad, what is right and what is wrong. And you need to make choices in uncertain environments, in unpredicted environments. The biological advantage of that is, as I said, enormous. Think about it. Being able to move into unpredicted, novel environmental niches and survive there. The only other way in which it can work is that great swathes of the species die off. And the ones who have happen to have the kind of behavior that enables them to survive there, they survive and they reproduce. And then that's the way in which a new homeostatic mechanism gets selected into the phenotype. But being able in your own lifetime to feel, this is bad, this is good, That means you don't have to die and wait for the next generations to be able to acquire this capacity. You can acquire the capacity during your own lifetime. It's called learning from experience. Please note the word experience. Experience is sentient being. It's feeling. And the feeling provides the value system of what is good and what is bad for us biological creatures. This is the function of feeling. It does something. It has a place in nature. It can be understood mechanistically. Now, because where I'm heading is mechanism, I've also put on the slide this word down here, entropy. What I've just told you about homeostasis and how it works is the essential feature of living organisms. Remember what I told you right at the beginning about Johannes Müller. And Müller said there's something different about living creatures, that they can't be reduced to the laws of physics and chemistry. There must be an élan vital, there must be a life force, some special vital energy that living creatures have that distinguish them from the rest of matter. And the way in which we are understanding this issue today in relation to the mechanisms that I'm talking to you about has to do with entropy. That what distinguishes living creatures from non-living creatures is we resist entropy. I don't have time to go into what entropy is all about. There's a whole story about it. It's a very basic aspect of physics, but everyone knows if you leave a battery standing, it will run down. The electricity, I mean, the charge will dissipate. If you put hot water into a cold bath, it doesn't just stay there under the hot tap, it dissipates. This is entropy. It's equalizing things, the difference in energies equalizes. And so this is a very basic property of all matter. It's the law of entropy. The second law of thermodynamics. Interestingly, thermodynamics is what Helmholtz was all about. In fact, Helmholtz was one of the inventors of the first law of thermodynamics, which is the law of conservation of energy. So the second law of thermodynamics is that everything that entropy always prevails, that the difference is always equalized, that this is how energy works. And how homeostasis works is the opposite. Homeostasis is, I'm not going to dissipate. I'm not going to become the same temperature as my environment. I'm not going to just merge, and I'm going to stay within particular preferred states. I'm going to work to remain in those states. That's how homeostasis works. It is a neg-entropic force. It's an anti-entropic force. This, if there's anything that is the life force that Johannes Müller was looking for, it's homeostasis. And I put the word drive there because drive, which those of you who psychoanalysts know, Freud defined drive as a measure of the demand made upon the mind for work by virtue of the connection between the mind and the body. That is exactly what I've just shown you here. Unpleasure, in other words, deviation from the homeostatic settling point, in other words, heading toward entropy, is drive. The drive is, this is bad, I don't want to be there, I want to be there. And so pushing us back this way is this is the demand for work. This is the work. And I'm using these words deliberately because these are basic mechanistic concepts about work in thermodynamics and in physics and so on. Because I'm saying ultimately we can explain consciousness in terms of the very same concepts that we use to explain the behavior of the rest of the universe. Again, I really have to hurry, so forgive me for skimming over all of these things so rapidly. But I do need to make one further point, which is this. Remember, the question that we're addressing is, why does it have to feel like something? I hope that the answer is beginning to emerge from what I've said to you. Why do we have to feel anything at all? I've told you why we have to feel something, especially when you realize that what we're talking about is literally feeling. Consciousness is feeling. If you don't feel your own hunger and your own thirst and your own core body temperature dysregulation, etc., you will die. Okay, so it's really very important why we feel like something. And I want to relate that again to this concept of entropy. That entropy, in other words, the law that governs all matter, is the thing we're resisting. What we're resisting is dissipation, is ceasing to be. is literally dissolving and equalizing with our environments, which I'm sorry to tell you, my dear colleagues, is what's eventually going to happen when you disappear from this material universe. You will dissipate. Entropy will win, and you will be spread from dust to dust, and you will literally become subject to entropy. But while we're here, we're resisting that. We don't want that to happen. We have a value system. It's the basic value system of biology, which is that it's good to survive and to reproduce. This is not my laws. This is the laws of biology. And there's a value system. It's regulated. That anti-entropic value system is regulated by drive. And how do we know our drives? We feel them. And why is that a good thing? I've told you why. Because it enables you to have voluntary action in the world, to make choices, which is an enormous adaptive advantage. It's how we stay alive and how we reproduce. It's very, very different from vision. Now, here's just some examples of higher emotions. When I say higher, I don't mean philosophizing, about guilt and social responsibility and shame and jealousy and things like that. I mean higher than hunger and thirst and temperature regulation. These are basic emotions. They are affects which do not have to do with the here and now control of the body. These are affects that have to do with things like maternal care, things like attachment bonding, things like getting rid of frustrating impediments to your wishes, things like staying away from dangerous predators, things like copulating and so on. These are basic mammalian emotions. And the point I'm wanting to make is simply this, which is that these two are homeostatic. That homeostasis, exactly the same mechanism, underpins all of these things. There's a pleasure and an unpleasure attaching to each of these categories of emotion. And even though they're much more complex than the basic bodily ones that I've spoken about, they work in the same way. Like take, for example, fear. When the predator or the persecutor is coming for you, then it is like this. I'm not where I want to be. I want to be safe. And then when you escape the predator, then it's like this. Phew, that's nice. Okay? And then you're back to satiation, you're back to the settling point, which is the need to not be about to be eaten by a lion. Okay? And the same thing applies to separated from mommy. And then, mommy, come back again. And then you're back in the settling point. They all work like that. All of the emotions work like that. I don't have time to go into all the details. I'm just wanting to make that point. But there's a crucial point embedded in what I'm saying, which I do need to underline, which has to do with this nirvana here. It is not, when you don't need to urinate, you don't think, I don't need to urinate, that's good, don't need to urinate. It's not on the radar, okay? I'm not too hot, I'm not too cold, that's great. You can think that if you want to, but you will never feel it. You only feel feelings when there's a deviation from the settling point. When you're in the zone, as they say, this is also why I'm joking. By the way, it's not only a joke. Those of you who Freudians will also know why I'm using this word, nirvana. Freud thought it was a separate principle, the nirvana principle. Actually, it's one and the same principle. The pleasure principle is in the service of the nirvana principle. It's deviations from nirvana. The crucial point that I'm making is that when you are in that settling point, you feel nothing. You get it? You're not feeling the feeling. And this is the ideal state of the organism. Unlike what Freud said, forget about Freud in this regard, think about what I'm saying biologically, that is the ideal. I do not need anything. It's a state of absolute satiation where every one of my needs has been met. Now, although we never get there, sadly, as you all know, we never get there. Nevertheless, this is the design principle of the homeostatic brain, of the affective brain. The design principle is you're aiming for satiation, which means you're aiming for no feeling. Feeling is bad. Bad feelings say you're getting away from where you want to be. Good feelings say you're heading towards where you want to be. But that's better than the bad feeling. But the best feeling is, I am where I want to be. And then you don't feel anything at all. It's called satiation. So this is the surprise in what I'm saying to you, is that the design principle of the affective brain is zombiedom. We want to be zombies. We want to have our needs immediately met. We want to know exactly what to do. That would be the ideal. And as it happens, that is exactly how it works. Thanks for the water. Now, I told you about these basic emotions. As it happens, I remember those words I used earlier about prediction and prediction error and surprise. We are born with predictions about how to meet all of these emotional needs, just as we are born with predictions as to how to meet all of our bodily needs. Things like the sucking reflex, for example, these are built into the phenotype, and just like thermostats, as I told you, these things can work automatically. And if you're just a very simple creature, like a worm, there's absolutely automatic, absolutely predictable, exactly what the worm's going to do under this, that, and the other circumstance, because their homeostats are absolutely fixed. They don't have feeling. They don't have the capacity to make choices. We do have the capacity to make choices. Why? Why have this troublesome thing called feeling? I told you why it gives you this enormous adaptive advantage to be able to survive and reproduce in unpredicted environments where everything is not predictable, everything is not automatically regulated. And therefore, when it comes to these higher emotions, and remember I'm using the word higher in the sense that I defined it earlier, although we are born with predictions, like the instincts and reflexes that I was telling you about earlier, they're not enough. We need to learn from experience what else to do. So, for example, in the case of fear, what the innate prediction is freeze. In other words, hope it doesn't see you. You don't have to think that. It's just that it's built into you. All mammals, they freeze when they feel fear. And then they flee. If freezing doesn't work, you run. You just hope for the best and you run like hell. This also you don't need to learn. But it's not enough. Imagine if in your life all that you ever did when you felt scared was freeze or run like hell. It's not enough. It doesn't actually work so well as all the subtleties of who to fear, who not to fear, who must you run from, who mustn't you run from, and so on. Same applies to, say, rage. The innate prediction as to what you must do if you feel frustrated rage is you must go roar and you attack and you hit the bastard and you get rid of him. That's what you're supposed to do. That's the innate prediction. Now imagine if you did that every time your mother frustrated you. Big problem, okay? Get rid of the bastard. Whoops, I need her, okay? And imagine if you do that every time your head teacher irritates you. Hit the bastard, okay? Well, he's bigger than you and he can expel you from the school and so on. These are very basic and silly examples of an actually very serious point, which is that we need to learn from experience. This is what feeling is for. Feeling enables us to be able to nuance these predictions, to learn what else we can do. How do we survive in novel, unpredicted, and complex environments? How do we meet all of these needs in relation to each other also? Because the example I just gave of attacking your mother to get rid of her contradicts this need, which is to keep her close to you always. And so it's very hard to learn how to meet your needs in the world. And this is why we have feeling. Feeling guides us in uncertain circumstances as to what the right thing is to do. Learning from experience is the function of feeling. But I'm saying again, remember that we don't want to have these experiences. What we want is to know how to meet our needs. So again, surprising as it may sound, the ideal design principle is zombiedom. I don't want to not know what to do when I'm scared. I don't want to not know what to do when I feel separation distress. I don't want to not know what to do when I feel sexually aroused. I want to know how to meet that need immediately. That's the ideal. As I said, we never get there, but that mustn't confuse us as to what the design principle is. So now I come back to this question. Why is the performance of these functions accompanied by experience? Why doesn't all this information processing go on in the dark, free of any inner feel? What a stupid question. Do you see? When you look in the right place, this question is far from perplexing. Feeling, why is the function of feeling why does it not have feeling attached to it? Okay. Now, look at the time. There's 20 minutes to go, and you still have to have questions. What this slide, please don't be alarmed. What this slide, which comes from Friston's paper, Life as We Know It, I'm showing it to you because when I read this paper, I was absolutely blown away with excitement. Because what Friston did in this paper, which was published in 2013, was to explain homeostasis. It's a very simple thing. Homeostasis, as I've explained it to you, is not exactly complicated. If homeostasis, and remember it's not only homeostasis like the thermostat, it's an extended version of homeostasis, which is feeling homeostasis. I've explained it to you in the basics. But what Friston showed in this paper is that the homeostatic regulation of a single cell and the homeostatic regulation of the brainstem, by the brainstem of all of these basic physiological parameters of the body, that this can be reduced to a mathematical equation, which is not surprising. I hope you agree with me. It's not surprising because it is in the nature of the sorts of things I've been talking about. It is a mechanism which has an inner logic which is entirely mechanistic. And therefore, it's not surprising that it should be possible to reduce these things to equations. Why I was excited when I read this paper was because the most obvious point suddenly occurred to me, which is that if the behavior of these upper brainstem nuclei that regulate our homeostasis can be reduced to mathematical equations, and if those very same nuclei are the ones that generate our affects, as they are, then, my God, it must be possible to reduce affect to basic laws. There must be laws underpinning the homeostatic mechanism of affect. Therefore, there must be laws underpinning the basic elemental form of consciousness, which means that the ideals of the Helmholtz school, the ideals of our old Sigmund Freud, that maybe one day it will be possible for us to explain all of these things in terms of physics and chemistry, and ultimately we can reduce it all to mathematical laws. When we realize that consciousness is actually something very simple, it is actually just feeling in its elemental form, and you realize that these are homeostatic mechanisms, it becomes plausible, it becomes possible that we might have within our grasp a mathematics of consciousness. And so that is why, after I read that paper, I became so excited, and I contacted Friston, and I said, you know, I think that what your paper suggests is this, the thing I've just said to you. And he says, gosh, I think you're right. So I said, well, maybe we should do something about it, and so we did. Now, in the few minutes, well, actually, it's 2 minutes left to me, if I'm going to have 15 minutes of discussion. I want to just say these last two things before we end. The second last thing I'm saying is that cognition suppresses surprise through prediction. I've already said that to you, learning from experience. That's what cognition is for. Cognition is for us to be able to work out, to feel our way through life's problems. Conscious cognition is for that, to be able to work out how to meet our needs in addition to, over and above, the instinctual reflexes that we're born with. So it's learning from experience is what cognition is there for. Remember, cognition is intrinsically unconscious. I've told you that right at the beginning of my presentation. Everything that cognition does is intrinsically unconscious. Why do we have to have conscious cognition? It's so that we can feel our way through our cognitions when there's unpredictability, when there's uncertainty, when choices have to be made. So cognition is to learn how to manage the feeling, to regulate the feeling, ultimately to damp down the feeling. That's the aim of cognition. It's, in other words, to learn how to meet our needs in the world. I'm sorry I don't have time to go into it in any more detail. You can read the papers that I gave you. But I do want to just make this one point, which is that the basic mechanism is right here in the midbrain. And I spoke to you about the reticular activating system, which arouses cortex. And remember, it's not volume. It palpates the cortex with feeling and with different qualities of feeling. That's what consciousness is. Consciousness is feeling your cognitions. It is the subject of the cognitions is you feeling your way through this information processing, which can go on in the dark if it's happening automatically. But where choices need to be made, you have to have feeling. And this is what the reticular activating system is doing. Then I want to just make this point, that the prediction errors, this is what neuromodulation, by the way, is. Neuromodulation is the palpating of neurotransmission in relation to uncertainty. And I don't have time to go into all the mathematics of that. But where the automatic algorithms of cortex do not work, there will be prediction error. The prediction error comes down to periaqueductal brain. Every single affective system of the brain, of the human brain, of the primate brain, of the mammal brain, of the vertebrate brain, every single affect system descends onto periaqueductal gray. Periaqueductal gray is where the residual error is registered. Periaqueductal gray is right next to the superior colliculi. And this is the most rudimentary representation of the external senses, non-conscious. And here's where the decision is made as to what to do next. And then reticular activating system recalibrates neuromodulation in relation to residual error. It's a constant loop like this. I'm sorry I don't have more time to go into it. As I said, you have to read the papers. Now, I told you all of this can be reduced to mathematics, and this is the most incredible thing. To me, it is absolutely, I would never in my wildest dreams, I'm a psychoanalyst. I'm not a reductionist. I'm not a right-wing materialist. I'm not an artificial intelligence geek. You know, I'm a feelings person. So to my very great surprise, I am led to the conclusion that it is possible to reduce feelings, to reduce consciousness via feeling to a basic causal mechanism. And I told you I wrote this paper with Kristen. It's one of the references I gave you at the beginning, based on that conclusion. And we wrote the formula, the equations. Here they are. There are three permutations. When there's prediction error, there's three things you can do. You can either act in order to make, so here's where I predict I'm going to be. I do this thing and I'm not there. That's prediction error. So what you can do is you can do something different in order to get away from the error. That's action. Perception is, I don't have time to go into it, read the paper. Those things, both of them, can be done automatically. The cortex can perform these algorithms by themselves. Affect, which is this modulatory mechanism, is the third thing you can do, which is you can change this palpating with feeling that I'm talking about. In other words, the uncertainty, regulating the uncertainty in relation to not fixed algorithms, not fixed action and perceptual sensory motor responses, but this neuromodulatory arousal function that the brainstem nuclei perform is affect. And in computational neuroscience, that is called precision. It's precision is the same thing as postsynaptic gain. It's what neuromodulation is. It's not the neurotransmission aspect of the signaling. It's the precision aspect, and you'll have to read that paper in order to be able to get all of this. I don't have time for it, but the point is that in principle, it is possible, not surprisingly, to reduce to an equation how this aspect of homeostasis works. This aspect of homeostatic control in conditions of uncertainty in relation to the basic mechanism that I've already described to you. Those of you who are Freudians might notice it gave me great pleasure to use Freud's, the symbols that Freud used in his original project for a scientific psychology. This was his symbol for consciousness. This was his symbol for memory. This was his symbol for perception. This was his symbol for action. And this was his symbol for energy. By the way, Q in thermodynamics means heat. Freud knew all about thermodynamics and all about the basic Helmholtzian framework within which this solution comes. I don't have time. I have to end. I want to just tell you that when I said to you that what the arousal is for is because we have to learn from experience. It's when the automated algorithms don't work, where we need to make choices. That's what feeling is for, as I keep on explaining to you. that arousing of cortex, that increasing of postsynaptic gain, that neuromodulatory function of the upper brain stem, is the mechanism of what in cognitive neuroscience we call reconsolidation. And that's why I'm showing you this paper. Memory traces are automatic things. They're unconscious things. They just do their thing. When they work, when they don't work and there's prediction error, they become salient. And then upper brain stem changes the precision, changes the postsynaptic gain, changes the parameters, and literally dissolves the memory. In other words, this prediction isn't working. You better rethink it. And I'm anthropomorphizing now because I'm speaking. This happens right down at the single cell level. So we have the mechanism whereby this works. Reconsolidation is how memory traces are revised, memory traces are changed, and it's driven by the reticular activating system. That's how ordinary neurotransmission does not result in this. It's neuromodulation that results in it. And so I just wanted to let you know that there it is. Okay, so conscious cognition is predictive work in progress. I hope that from what I've said to you, you get the idea. That prediction is automatic. When it's not working, there's error. Then you have feeling. Then you need to reconsolidate. And then the memory trace becomes conscious. It becomes salient. It becomes labile. It is no longer a trace. It's now a state of consciousness. Conscious cognition is predictive work in progress. When the predictive work has been done, then you go back to the automated algorithms. And as I said, that zombiedom is the ideal state of the organism. We're trying to get things from declarative memory into non-declarative memory. We're wanting to automatize everything. That's the ideal state. I don't have time to go into it. I'm at the end of my talk. So the question we began with, why and how is there something it is like to be an organism, something it's like for the organism? Remember, Nagel said we have no clue how this works. And I'm saying to you, after everything that I've reviewed for you, really, we have no clue how this works? Why and how is there something it's like to be an organism? In other words, why and how does it feel like something for the organism to be in states of need, to be in existential crisis? I am hungry, I am thirsty, I am too cold. I'm going to die is what it means. Why should that feel like something? For fuck's sake, why should it feel like something? Because you're going to die, you know. It's really important to know that that's bad, and it guides what you do in terms of the hedonic valence and the particular quality of which need is not being met, the capacity to make decisions, to make choices, free will. To be able to do that is what feeling is for. That is why and how there is something it's like to be an organism, something it's like for the organism. I hope that everything that I've told you gives you just a clue that it might be possible to solve this problem after all. Thanks very much.